Hello everyone and welcome back to our channel. In our previous discussion, we explored one of the controls of automotive cybersecurity, that is the intrusion detection system IDS. Today we'll be discussing the intrusion prevention system IPS. We'll delve into what an IPS is along with its importance and some of the challenges associated with implementing these systems. So without further delay, let's begin the discussion.
Okay, so let's begin. So, what exactly is intrusion prevention system? Previously, we saw that intrusion detection system was a system which used to detect the malicious attack. But the intrusion prevention system is something a more extended and advanced version of it, which is a crucial security technology designed to do more than just to detect the threats. As I just now talked about, like intrusion detection system was only used to identify the potential issues, whereas an IPS actively prevents malicious activity. It works by analyzing the network traffic in real time, identifying all the suspicious or harmful behavior, and taking immediate actions against those to block these threats. This proactive approach helps to safeguard our systems by stopping attack before they can cause damage. So why is the intrusion prevention system important? Its main role is to protect against the malicious attack, ensuring the safety and security of the vehicle operations. By stopping the threats in their tracks, an IPS helps maintain the integrity and functionality of the vehicle system, providing peace of mind and enhancing the overall security and safety. Now, I would like to ask Dharmesh to explain a bit more about how exactly this intrusion prevention systems can be implemented within the vehicles and some interesting facts or information about this IPS.
Many thanks, Riva, for outlining the IPS. Now let's see how does it works as a backend system. So in this example, IDS and IPS works together. So let's see how it works. So we have attacker and we want to protect all the vehicle communication against the malicious activity performed by this attacker. So step one, as Riva also mentioned in overview, that we last video we seen how it will be detected using the IDS system. So step one will be performed here is with the IDS. Then whatever the malicious activities it is detected, that will be reported to the backend system. So which is nothing but the SOC. So SOC stands for Security Operational Center for the further analysis. So SOC could be powerful AI or ML systems which will analyze whichever the data sent back to the system and identify the patterns within the data sets for the malicious activity. Now, additionally, this SOC could be also a human like expert team which will analyze manually using certain tools available. Once the analysis is completed, they identify certain action needs to be performed. So step number 4 here would be to prepare a response. So once this response is prepared, then next step would be to deploy that fix into the vehicle. So generally, most of the vehicle, this fix will be provided to the vehicle via the OTA or some kind of software patches. So this is how the IPS here works as a backend. To note here, one point is that this IPS is not real time. This prevention will be performed later part in backend. So going forward in future, if certain activities again comes up, then we already have fixed and it will be prevented. So in that way, this is the IPS system works as a backend. Now let's see one more example where The automotive firewall works as a IPS, and this will be the real-time one. So what is automotive firewall? The firewall enforces strict access control, ensuring that only the authorized devices and services can be communicated within the critical vehicle systems. So basically, it's similar to what firewalls we see in the network, in the internet also. That is basically has certain predefined rule in it, and based on this rule, the traffic will be passed from input to the output. Now let's see what are the major types of Ethernet firewalls available in the automotive system. First one is stateless packet inspection firewall. Now what this firewall means? So it acts by inspecting the packet transfer between two network zones. When a packet does not match the set of filtering rule in the packet filters, the packet filters either will be dropped or rejected, else it will be allowed to pass. So which kind of rule we are setting, based on that the action will be taken here. And what kind of rule we are setting in this type of firewall is the packet may filter based on the Ethernet header, IPv4, IPv6 headers, or TCP UDP packets. So these are some of the examples how the stateless packet inspection firewall will be implemented. The second type of firewall is stateful packet inspection firewall. So a stateful firewall can grant or reject access to the packet not only based on the ports and protocol, but also based on the multiple packet attributes which stored in the memory as a state table. Now what this state table consists of, this may include the details like IP address, uh, different protocol ports, also the TCP flag like synchronous or acknowledgement or FIN number, etc. There is also third type of firewall which known as deep packet inspection firewall. This kind of firewall evolves beyond the simple stateless packet filtering or stateful inspection firewalls. It involves deep inspection of the packet at the very specific application layer, and it's specially designed for certain different protocols. For example, uh, DOIP protocol, diagnostic over the IP, or DDS, which also known as data distribution services, or some IP, service oriented middleware E over IP, to prevent advanced attacks. Now let's see how this firewall will be deployed within the vehicle system. So for the deployment also, there are two types. One is host-based firewall, a firewall on small end issue, which typically cater to verify certain use cases, and it is only for the issue level. For example, electronic vehicle charging issue, to monitor the charging related traffics and prevent set certain rule to prevent certain attack. Another another type of firewall deployment is network based firewall. So as we know that modern vehicles have smart Ethernet switches, and the firewall requirements are complex as well as performance intensive due to amount of network traffic goes for these switches. So typically the firewall is paired together with the router in the switches to perform the network separation and access control for other issues and cross domain traffics in the network based firewall. So in this image, as you can see, it is depicted as example zonal end-to-end architecture, E2E architecture including firewalls. You can see both this type, host based and network based, are depicted here. The right hand side, you can see these are the issue levels. So we can consider this as a host based firewalls, whereas there is also firewalls at the domain controllers, also at the switches and at the server. So these are nothing but our network based firewalls. Apart from implementing this IPS system, there will be some challenges uh, because it's not so popular within the vehicle. So what are those challenges to implement this IPS system will be explained by Riva. So over to you, Riva.
Okay. So let us talk about the challenges. Like in IDS also, we saw some of the challenges while implementing this uh, system to the vehicle, and in IPS also we have some of the challenges. I can see the first and the second one is already the ones which we have discussed, like limited resources. As we know that inside an ECU there is some kind of restriction for the storage of the data or the data transmission rate or some other things. So because of that restrictions, implementing this IPS intrusion prevention system is difficult or maybe challenging, because the IPS must function efficiently without consuming too much memory or processing power, which would otherwise impact the performance of the essential vehicle systems. So due to this, and the second point which we have seen is the cost implications. As we know that implementing this IPS systems can be costly, since they are enhanced security measures. So you may need to drive up to the expenses for the development, installation, and the maintenance for this. So it also may be one of the challenges for the automotive manufacturers. The third point, which is something new for the IPS, which is service disruptions from IPS. Sometime what may happen is IPS may occasionally block the legitimate vehicle communications if it misidentifies them as a threat. Then this could lead to some disruptions in some of the essential vehicle functioning, such as navigations or braking systems. So it is crucial for the IPS to strike a balance between the security and functionality to prevent the disruptions that could affect the driving experience or the vehicle safety. The fourth point we can see here is the need for precise configuration. Effective development of the IPS required meticulous configuration in order to avoid the more number of the false positives. Where these false positives are nothing but the safe activities which are incorrectly flagged as threats. So this process involve understanding of the vehicle's communication patterns and adjusting the IPS accurately distinguish between the genuine threats and legitimate operations, ensuring the reliable protection without unnecessary disruptions. And the last point which we can see is limitation to threat detection. So basically, the IPS system rely on the signature based detection to identify the threats, which means that they require regular updates to recognize new or evolving threats. Without these updates, the IPS may fail to detect the emerging risk, leaving the vehicle potentially exposed to unknown threats. So the ongoing updates and threat intelligence are very essential when it comes to maintaining the effective protection to the vehicle. So these were some of the challenges which could be faced while implementing the IPS system in the vehicle.
So I have a question here. So what type of attacks can an IPS help prevent in automotive settings?
Okay, that's the good question. So as IPS is a intrusion prevention systems, so it will mostly prevents the malicious attack which is performed on the vehicle networks. But apart from that, you can also include the data breaches attack or some kind of traffic is ongoing, then recognizing the pattern and finding out some suspicious activity within the traffic and prevent them. Also, the denial of service attack can be prevented using IPS system. So
Mm.
these are the some of the examples through IPS we can prevent this.
Okay, so one more question I have is like, what are some of the future trends that we can see in automotive IPS technology?
Yeah, that's the interesting question. Since the IPS, even you would see it's not mostly you can see it on search, web search, or it's combining with the IDS. Or so independent IPS system currently it's uh, very hard to find or hard to implement. So future trends, some of the future trends we can see on the IPS system. One of them would be the artificial intelligence and machine learning integration for the IPS system to analyze certain kind of traffics or algorithms in a faster way, and that can provide the fix uh, in a certain way or a faster way. The second one is enhancing the communication security. So more secure communication protocol and encryption method will be used, uh, and whichever the technologies are performed. So identifying that and setting up rules for them as IPS rules uh, in the IPS system. That will be also something future trending part. One more trending part would be the cloud-based IPS solution. So currently, cloud-based is mostly we can see it on internet, where normal traffic will be monitored or prevented. But also in the automotive domain, since the future would be the connected cars, then more and more data would be on cloud or server. Then this also something which will be on the train to have some kind of cloud-based IPS solution. So I think yeah, these are the some of the future trends what we would see in the IPS technology.
So, in the firewall, we may find new types of attacks in future. Uh, so, how we can update our firewall to prevent these new types of attacks?
Okay, so that's the good question. So generally in PC, normal PC or internet world, when the firewall is implemented, there is some kind of filters and the rules will be set. So in future, if we identify or antivirus is finding certain kind of rules, then again we can change these filter settings and configure the new rules in the firewall, and that will be implemented similarly on the vehicle as we seen here. For the different type of firewall for the Ethernet, we have different configuration like source address or destination address, also IPv4 6 headers, also some kind of TCP flags like synchronization flag or asynchronization. So if we identify something is we are not checking the flag and due to which the attack happen, then these settings we can enable or configure in the firewall. So this will be then prevented from the going forward. So yeah, there are settings or configuration available which can be changed and firewall will be implemented.
So in our previous session, we have seen about the intrusion detection system, and in today's discussion, we just discussed about the intrusion prevention system. So I just wanted to know, how does an IPS differ from an IDS?
Okay, so if I may answer, so IDS, as we discussed last time, it's mainly for detecting if any attack is performed or in within the network, if any uh, anomalous activities is ongoing. So just to alert the user that something is going wrong in your system, we use the IDS. But IDS will not prevent or it will not stop for that particular signal, or you can say that the data to pass to the target issue. That's where the IPS will come. So IPS, if any flag is raised and it will detect that something is not going according to the settings, then it will block that particular data to be processed further. So it's basically preventing this kind of attack where IDS will just alert the user, and then user's responsibility what to do with this, whether uh, to provide the fix for this in future or analyze this or drop it or pass it. That's up to the user. But for prevention, we are preventing that.
So that wraps our discussion on the intrusion protection system in automotive cybersecurity. We hope you found it informative and engaging. Drop your questions or thoughts in the comment section below. Don't forget to like, subscribe, and hit the notification bell for the updates. Thanks for watching and see you in the next video. Until then, have a great day.